Hello, this is the network design for Group 10 for the CNT 4703 project. There are 3 members in this group: Carlos Beltran, Dale Driggs, and David Rooney. The project description is an overview of the network and the project. This network design contains 3 primary departments, each holding a certain amount of hosts. Department A holds 10 hosts, Department B 60 hosts, and Department C 200 hosts. Moving forward, we have more requirements to this network. The design consists of 3 routers, one router directly connecting to the internet, the second router which connects to the 3 switches in the network design, and the third router that connects the remote host to the network. There are also 3 switches in this design. 2 switches will stem from one main switch that is connected directly to the router, and then finally we have 2 servers which are used to hold all of the data that is created from all of the departments in the network. Moving on, Carlos will explain the diagram.
Thanks, David. This is actually Dale Driggs, and I will be going over our physical design. The slide you see now is how our system is laid out, and throughout the next couple of slides I will go over each individual component and just give a real light summary of the details for that component. Here is router 3. It is the one that is connected to the internet and gives the rest of our network access to the internet. On Fast Ethernet 0/0, we have it connecting to the internet, and then it has a serial interface. We're using 0/0/1 on a 10.10.10.6/30 network to connect to router 2. Here we have router 2. It's quite busy, so I'll begin with the serial interfaces. First, we'll go with 0/0/0. It gets a 10.10.10.5 IP address with a /30 subnet. And on the right, we have a 0/0/1 serial interface. It gets 10.10.10.2 with a /30 subnet. For our fast Ethernet interfaces on port 0/0, it gets 10.10.14.1 IP address with a /23 subnet. And on the right, we have our 0/1 port, which is our trunk port for aggregating all VLAN traffic. This is router 1. Serial interface 0/0/0 has an IP of 10.10.10.1, has a /30 subnet, and its fast Ethernet interface port 0/1 has a 10.10.12.17 with a /28 for communicating to other hosts. This is switch 1, its fast Ethernet interfaces. Port 0/3 is for communications to router 2 for all network communications. 0/9 is its trunk port for aggregating all the VLAN traffic to router 2. 0/7 is for communication with switch 3. 0/5 is for network communications to the server on switch 1. And then 0/1 is for communications to switch 2. This is the server connected to switch 1. It has an IP address of 10.10.14.2 as a /24 subnet, and it looks for its gateway at 10.10.14.1. Here we have switch 2. Its fast Ethernet interfaces, its port 0/5 is communicating to switch 1. Its port 0/1 is for communications to VLAN 2 for Department A. and then 0/3 is for communicating to the server located on this switch. Here we have VLAN 2, that's for Department A. The hosts begin at IP 10.10.12.3, subnetted at /28. They look for their gateway on 10.10.12.1. And then we also have the server here, and that gets an IP of 10.10.12.2. And it's also on the same /28 subnet, and it's looking for the same gateway at 10.10.12.1. Here we have switch 3 on its fast Ethernet interfaces. It's port 0/3 is for communications to switch 1. Its port 0/5 is for communications to Department C, and that'll be VLAN 4. And then its port 0/1 is for communications to Department B, which is its VLAN 3. These are the two VLANs located on switch 3. For the first one, we have VLAN 3. That's for Department B. Its IP range begins at 10.10.12.66/26. That's for the hosts. Those hosts are looking for the gateway at 10.10.12.65. The other VLAN, VLAN 4, for Department C. Its IP range begins at 10.10.13.2, and it's a /16 subnet, and those hosts are looking for a gateway at 10.10.13.1. This slide denotes our router setup and design with all 3 routers displayed. All this information was already gone over in the physical design, so I won't reiterate it here. The only key piece here is router 2 has 3 sub-interfaces, which I will get to in a moment. Here are the sub-interfaces for router 2. Our 0/0 is for routing all normal network traffic, and that falls on our default VLAN, VLAN 1. Our second interface is our 0/1. Key here is 0/1.2 is our Department A VLAN, 0/1.3 is our Department B VLAN, and 0/1.4 is our Department C VLAN. This is our routing protocols that our routers are using, and we are, as the slide denotes, using RouterRIP version 2.
This is our switch design. We used trunk ports, and this is required for VLAN information to be passed in between the switches. For switch 1, it is connected only to a server. Switch 2 is connected to VLAN 1 and a server. And then switch 3 is connected to 2 different departments, VLAN 2 and also VLAN 3.
This slide just recaps our VLAN design. From David, Carlos, and myself, we would just like to say thank you for listening, and we hope you enjoyed our presentation. Have a good one.